This lecture is for Chemistry in the Earth System, continuing Unit 1.1. Topic, heat. The essential question for this lecture is going to be how can two objects of different masses have the same temperature but different amounts of thermal energy? A little bit of a long one, but how can two objects with different masses have the same temperature but different amounts of thermal energy? Temperature is average kinetic energy. Temperature is average kinetic energy. Recall the earlier lecture about the difference between temperature and thermal energy. The question of how two objects of different masses can have the same temperature but different amounts of thermal energy is a question of comparing an average to a total. Assume that a 500-liter section of ocean and a 1-liter bucket of seawater are in your hands. If the particles in both samples move with the same range of speeds and have the same masses, then the range of kinetic energies will also be the same. The average of these kinetic energies must also be the same. Therefore, both the 500-liter and 1-liter samples of seawater have the same temperature. On the other hand, the two masses of water will not have the same total thermal energy. This is because there are many more particles in the 500-liter sample than in the 1-liter sample. The total kinetic energy, or thermal energy, of the ocean water is about 500 times greater than that of the water in the bucket. Specific heat. Specific heat. The amount of total energy in the section of ocean and the amount of total energy in the bucket of seawater at the same temperature were different because of the different amounts of mass. Even if two objects made of different substances had the same temperature and mass, they still might have different amounts of total energy. The abilities of materials to absorb and release thermal energy vary. The amount of energy required to change the temperature of 1 gram of a given substance by 1 degree Celsius, or 1 Kelvin, is considered to be its specific heat. Specific heats are typically given in units of joules per gram Kelvin or joules per gram degree Celsius. And please pay careful attention to the presence or absence of a kilo prefix to any of these units. You may see units of kilojoules or joules, and you may see units of kilograms as well as grams. So please be certain you are double checking your units. For equal masses, or two objects or substances with the same mass, different materials require different amounts of energy to achieve the same temperature change. Conversely, given the same amount of thermal energy, equal masses may achieve different temperature changes if the masses are not made of the same substance. If we use an example of playground slides, one can be made from steel and the other from plastic. Steel has a specific heat of about 0.5 kilojoules per kilogram Kelvin, while plastic has a specific heat of about 2.0 kilojoules per kilogram Kelvin. The steel slide's significantly lower specific heat causes it to achieve a higher temperature than does the plastic slide. So a lower or smaller specific heat results in a greater temperature change compared to a substance with a larger specific heat capacity. Now, if a substance has a low specific heat, to reiterate, it takes relatively little energy to change its temperature. If it has a high specific heat, it takes a lot of energy to change its temperature. A substance with a high specific heat resists changes in its temperature. Among common substances, water is very unusual in that it has a high specific heat of 4.186 kilojoules per kilogram Kelvin. In other words, it would take 4.186 joules to raise the temperature of 1 kilogram of water by 1 degree Celsius. Changing the temperature of water, therefore, involves a lot of energy. At this point, you should be able to fully and completely respond to today's essential question: how can two objects of different masses have the same temperature but different amounts of thermal energy?